So today what we're looking at is what do we do if we want to find the exact, not an estimate. Note this says exact value and when it is not on the unit circle. Guys, when it's not on the unit circle, we use SOHCAHTOA. Okay? Here are our steps. Rewrite the inverse trig function as an equation. Sketch the right triangle. Find the missing side and evaluate the trig function. Let me show you how easy this is. It seems like a lot of steps, it's not. We are going to take what's inside here and we're going to use that to draw a right triangle. So the first thing I'm going to do is sketch my right triangle here. I'm going to put my theta right here. Now, TOA, this is tangent, isn't it? So basically this is asking me to find the cosine of theta. Now, the cosine of theta comes from the triangle we're going to draw using this, because this is theta. Inverse tangent is theta. Now, tangent is also opposite over adjacent, isn't it? So guys, if we have inverse tangent of 1/2, tan inverse of 1/2 really means this is opposite and this is adjacent, isn't it? Does everybody understand that? That's where my SOHCAHTOA comes in. That's opposite and that's adjacent. So what we're going to do is we're going to go into that right triangle we drew, and opposite that angle, we're going to put the top number, 1. Adjacent would be 2, would be down here, wouldn't it? So now what I need to do is find that missing side, the hypotenuse, using the, and this is going to be Pythagorean theorem. So we know that 1 squared plus 2 squared equals c squared, don't we? So this is 1 plus 4. So c squared is equal to what? 5. So c is just the square root of 5. So this is the square root of 5. Now, this is telling me to find the cosine of theta. Cosine is what? So looking at that right triangle, what is the side that is adjacent to that angle? What is the hypotenuse? Square root of 5, isn't it? Okay, and if we simplify this, we get 2 root 5 over, and that would be our answer. So you're going to take the inside part to draw your triangle, use the Pythagorean theorem to find the missing piece, and then you're going to do whatever it says on the outside using that triangle you just filled in. Make sense? Told you it's not hard. So let's try this one, and then I'll let you try a couple on your own. Inverse sine, -1/4. Now for this guy, I'm going to draw it this way because I need to know where sine is going to be -1/4. Now remember, this is inverses, so which 2 quadrants? We have to pay attention to the quadrants, don't we? Which 2 quadrants does inverse sine let us use? First and fourth. So which quadrant, if this is negative, which quadrant am I drawing this in? The bottom one, all right? So this goes, my right triangle goes here, which means this is the positive. Let's see, this is opposite, and this is what? Hypotenuse, isn't it? Isn't sine OH? So opposite is, here's my theta. So opposite is what? That gets my negative, doesn't it? Isn't it below? What's your question, Allie?
How do you know which corner the theta is?
Theta is always the one connected to the x-axis. Okay? If I'd been a really good teacher, I'd have said, okay, tangent is first and fourth quadrant. and drawn it in the coordinate axis. So if it tangent's positive, it has to be in the first quadrant, doesn't it? That's why I drew it up there. Notice that theta is attached to the x-axis. This theta is also attached to the x-axis. Always attach theta to the x-axis. Good question. And that 4 is the hypotenuse, so that 4 goes here, doesn't it? Do you see your drawing will tell you which piece is negative, won't it? Now, Pythagorean theorem says I need to find this side right here, don't I? So we'll call that, we can call it A if you want, and then fill it in. So A squared plus B squared equals C squared. And we always know the slanted side is the hypotenuse, right? So this is A squared plus 1 equals 16. So A squared equals what? So A is, so this guy right here is the square root of 15. Now I need to find the cosine of theta because this is cosine, correct? And this whole thing right here represents theta. That's the whole reason we're building this triangle to begin with. So cosine is what? Adjacent over hypotenuse, isn't it? So which side is adjacent? Root 15. And what is the hypotenuse? And this is positive, isn't it? Okay. And that's the answer. Ava, what's your question?
I didn't know if that was.
Yeah, because the root 15 is your x is positive there, your y was negative, wasn't it? See, the picture shows us. In first quadrant, right there on that axis, the x is positive, the y is negative. All right, so let's draw. See if you can draw this in. This is cosine is positive, so which quadrant is this triangle going to be in? Yeah, because remember, this is first and second quadrant, isn't it? So we're going to draw it this way. Theta goes here. So can you fill in your 2 and your 3? Cosine is what? Adjacent over hypotenuse. So where does the 2 go and where does the 3 go? Fill them in. Where does your 2 go? Where does your 3 go on this triangle we drew? Adjacent would be here. Hypotenuse would be here. Did you get it right? Good. Now find your third side. 3 squared plus, I'm sorry, that's wrong. Be careful. 2 squared plus b squared equals 3 squared, doesn't it? Okay. So b squared is equal to 9 minus 4. So b is equal to what? Square root of 5. So this is square root of 5. Now from there, can we find the tangent of theta? Remember, this is opposite over. So opposite of theta would be what? And adjacent would be? Boom. You got it. Now, I want you to look at number 4. Number 4 says secant of inverse tangent of 8. Well, up to this point, we've had a ratio for that, haven't we? How can I write 8 as a ratio? 8 over what? Oh, just make it a ratio by putting it over 1. So what is tangent? So this is my opposite and this is my adjacent, isn't it? What quadrant is this going to be in? Yeah, it's positive. Tangent is positive in the first quadrant. There's my theta. Fill in your O and your A. Opposite would be here. Adjacent would be here. Find your hypotenuse, right? Find it and then secant. What is secant? It's 1 over what? So if cosine is equal to adjacent over hypotenuse, what is secant then equal to? So then use that to find the secant of theta. See if you can find this. And then check your answer and see if you got it. Did you get it? How are we feeling about this? Pretty good? Seems pretty easy? Good. You guys try secant, cotangent. So now I've given you 2 reciprocal functions, haven't I? If tangent, remember, cotangent is reciprocal of tangent. So what is tangent? Opposite over adjacent. So cotangent's going to be what? Yeah, adjacent over opposite. Got to turn this into what? Oh, what quadrant is this one in? Good. So we got to draw this in the 4th quadrant, don't we? Now, which piece gets the negative? Did anybody put the -2 right here? Why is that wrong? Isn't that a positive x? Doesn't -2 over 1, couldn't that be 2 over -1 also? So should it be -2 over 1 or 2 over -1? Yeah. So you're going to have to watch that, guys. Be careful. This is not negative, is it? This is. So pay attention to what your x and y values should be. Okay? Did you get it? Square root of 5 over 2? Make sure. Same steps every time. The hardest part's going to be on ones like this, figuring out which one gets the positive and which one gets the negative, isn't it? And that's based on the quadrant. Okay? So now, are we good? Fine, right? So inverse cosine of what? Inverse cosecant. How do we do them if they're just the inverse? And we're trying to do this on the unit circle. Do you have your unit circle out? We usually don't do inverses unless we have our unit circle out, unless it says exact value and you know it's not on the unit circle, like none of the rest of those were. How do we do them if they're on the unit circle, but they're these reciprocal values? Put your phone away. Oh, you're getting your unit circle out. Okay, I beg your pardon. I remembered that just about the same time I was getting onto you. All right. What is cosecant? 1 over what? So this would be 1 over the inverse of sine. Well, how does that work? But the inverse of sine of what? It can't be 2 root 3 over 3, can it? Yeah. You gotta flip this. So if we flip that over, we get what? 3 over 2 root 3. And we end up, if we simplify that, what value on the unit circle do you think that's going to simplify to? Guys, which value on the unit circle has a root 3 in it? You are correct. I'm trying to get the rest of them to the actual, what? Guys, if it has a root 3 in it, we only have 1/2 root 3 over 2 and root 2 over 2, don't we? So which one of those does it look like if you flipped that over? If you flip this over, which one of those 3 do you think it's going to be? Yeah, root 3 over 2. So we're going to rewrite this to say this is 1 over. Actually, we don't even have to do 1 over. Excuse me. We can just do the sign of the reciprocal. Can't we? Beg your pardon. Where is inverse sine of root 3 over 2? In other words, where is sine root 3 over 2? So this is where we draw our thing, right? And we say sine is first and fourth quadrant. So where is sine root 3 over 2? Wouldn't that be up here? Do you agree? So what is that value? Pi over what?
3.
Pi over 3. Pi over 2 is in the middle. So the answer to this would be pi over 3. Now, do you see what we did? We took the reciprocal of this and we flipped that. Recip flip, I like to call it. So let's try it here. What is the reciprocal of secant? Oh, well, actually, this we don't even have to take the reciprocal, do we? So for this one, it didn't ask us for the reciprocal. So what is the secant? What is the reciprocal of secant? This is the same as 1 over the what? Cosine of 0? Okay, so what is the cosine of 0? Look on your unit circle. You sure? What is the cosine of 0? That would be the x value. Guys, for this guy, it would be here, wouldn't it? Cosine of 0 would be out here. That's 0, so it would be 1. So it would be 1 over 1, which is what? 1, isn't it? So if it doesn't say inverse, then we don't recip flip, do we? We just do the reciprocal and find the value. That's the only one like that. Now, arc cotangent, is that an inverse? Yes. So this is where we do recip flip. So what is the reciprocal of cotangent? Come on, guys. What if you flip cotangent over, what do you get? It's the easiest one. Cotangent. What is the reciprocal of cotangent? Tangent. Inverse tangent. What do we get if we flip 0? Don't get 0. 0's in the top. We flip it over. Where does it go? The bottom. So if 0's in the bottom, what is it? Yes, undefined. So where is tangent undefined? Y'all are killing me. We did this. Look at your flip thing. We actually, it's where? Thank you. Yes, pi over 2. Tangent is undefined at pi over 2 and negative pi over 2, isn't it? Okay. Arc secant. What is the reciprocal of? Hang on. And then we got to flip this over. So if we flip over negative root 2, what does it become? Negative root 2 over 2. So let's draw our thing. What is cosine? First hand. So which one's this going to be in? Second quadrant in the middle, right? So what is the second quadrant value in the middle? Look at your unit circle. Second quadrant in the middle. 3 pi over 4. So the answer to this is 3 pi over 4. Try this one on your own. Recip, flip it. What is the recip of this guy? Reciprocal of secant? What is the reciprocal of secant? Cosine. So inverse cosine. And if we flip that guy over, what do we know it is going to be? So negative root 3 over 2. So which two quadrants are we doing? First and second. Which one is this guy going to be in? If cosine is negative, which quadrant is it going to be in? Second. This will be a long short, won't it? So it'll be over here. That is at 5 pi over 6. So my answer is 5 pi over 6. Get it? If we do recip, flip, what's the reciprocal of cosecant? So inverse sine. If you flip over negative 1, what do you have? Negative 1. What two quadrants do we do for sine? First hand. Okay, so where is sine negative 1? Down here at the bottom. Good. We don't call it 3 pi over 2, do we? We call it negative pi over 2.